Hello everybody! So today I thought I'd do a video exclusively about errors and some of my top favorites because even as a beginner or advanced programmer we all make mistakes, and if you know what types of errors there are then you can solve them faster. So let's get to it. So I said I was going to talk to you about errors today. So we have another video that I've posted below, and that's the syntax, semantic, and runtime, but I'm just going to show you some instead because I think it's easier. So for instance, if I remove the semicolon here and run, this is going to be a compiler error because it won't compile. It will show me up now in this. Here we go. My syntax error because the syntax being the rules of the language aren't being adhered to, and in this case it's the semicolon. Compiler errors consist of syntax errors, missing brackets, semicolons, and things like that. Or maybe if you put in a method within the main method, that can also cause a problem. So if we just do this, and if I move that down to just below here, so it's now nested, and a method that's nested which isn't allowed. And you can see here there's another error, and this is an unresolved compilation error. It's also a syntax error. There is complete block statements, and it goes on, and you can click on it and it will actually highlight it for you. So the other type of error that is there is the fatal logic error, or the non-fatal logic error, which we talked about a bit yesterday when it came to the arrays. Because if I was to go from, so the length of the array is always different to the index. So the length could be initialized as 10, which means there's 10 elements in it, but the index goes from 0 to 9. So if I was to assign based on a counter in a for loop, only from counter is equal to 1 based, and then counter is less than the array.length, that only goes from 1 until the array length index 9. So counter is less than the length, which is 10, so 9. So then it's only putting in values from 1 to 9 and not 0 to 9. So we're missing, so there's things like that isn't a fatal logic error, it's just a non-logical error, non-fatal logic error, because it's not going to break the program or anything, it's just misreading. It has one of the values that are missing. The other thing that is important as well is string literals. So if I have, for instance here, if I remove that and press play, and then if I look here, we have the exception called a string literal is not properly closed by a double quote. It even tells you, and it tells you what line it's on and everything. So you can just put in your double quotations here. The thing about Java all the time is that everything needs to match. So if we have also a type mismatch. So if I was to put in, so this is a precision 1 floating point, so which means it has 1 point after the dot, 1 number after the decimal point. So if I was to put in, let's say S here instead, so for a string, but it's actually for a float, that's going to only put it up here as so. However, because it converts it to a string, so that's really useful. However, if I was to put a D here There will be a format specifier check, which is incorrect. So illegal format precision exception, which is one of the things that we spoke about in the earlier videos when I said about the Java security and how it truncates if you have an integer or a double, because it's going to cut off the decimal after every decimal point, obviously. And I think I even used a little can to describe that. So you can only fit as many integers in there. The other thing as well, so that's the nested methods. Incompatible types can also come in the form of if you have a method, for instance, here we have a double average, but if I wanted to return a different or call something else here, so when I call an average, if I call it here average, and then if I pass in let's make D1 an integer and show you what happens, because it's going to be a type mismatch. So it's an illegal conversion. If I make D1 a string, capital S, because it's a reference type, and then make a 10 here, seed, and it also catches this and it says that it's not applicable. So it says the arguments are wrong. It tells you. So that's also good because it's telling you that the arguments are wrong. Now I just put it back to what it was. The other one is a return type required. So if we have our definition here of our method and it has public static double average. So if I either forget a return statement, then it's going to ask me for a return statement because you have to return it if you've already declared here. It says here this method must return a result of type double. It tells you explicitly. In the earlier versions of integrated development environments, it didn't tell you. So we're lucky that we have these tools now to tell you exact errors. So the other one is, oh yes, a very, very, very common one is a missing. And when the programs are huge, when they're really, really big, when you're in the work context, then it's even harder because you have to go all the way down and then try and match up all of your curly brackets throughout. But it actually tells you to complete class body. It tells you in the console here that it's a syntax error. Or if I have two missing, it will tell you not just that that it needs to complete the method body, and then the next one is going to be the class body that's needed as well. The other one as well is usually it's reached end of file while parsing is another thing. So it's parsing all the information and then it's reaching the end of the file and it's going, where is my curly bracket? Quote marks, not using the escape. So within the quotation marks we have a string. So if I was to declare a string here, test equals, oh yes, here's a good one. And then if I wanted to output also test here, but also test equals, and then presented s lowercase, and we have here initialize variable. It actually shows up straight away what it is to do, but some of the errors that can happen over longer things might need other things. So this is the initialization error with a string. However, we know that the default of a string is null. So you can also get a null pointer exception if you're using strings within arrays and you don't have a default set. That's really important because when you go down through the array, if you're going through different things, and then it says null pointer exception, which means it's pointing to nothing, it's pointing to null, and null is the default for string and false is the default for boolean. And then if you know the defaults already, then you can figure out that that these things are already there. So if I just put in this as an empty string, it will run and there won't be anything here, and that's it. It just won't have anything written in it. I should put a %n so it's clearer. And now it just has an empty because it's empty up here. The other one as well is known as a segmentation fault, where your array index is causing a buffer overflow. So if you have something like a non-negative integer, so if you have a non-negative integer, if you have like assigned the array index to a -1, that's not allowed. But that will be a segmentation fault, and that will be a runtime error. Then we have things like logic errors as well, which we spoke about as well, because the logic errors and the security errors when it comes to integer to double and casting as well. When you cast, you can't do a cast with an integer double because the upgrade to the next type isn't sufficient for Java. So there are certain constraints, and the reasoning behind it is that it's going to truncate the rest of the information. So if you have the default for a floating point for a decimal is 6 numbers, but you can specify how you print it out. So we have it printed out as 1, that we only want 1, but if I was to just leave it as an F, it will print out all. We don't have a dot in it. That's also another error with the unknown format conversion exception. That's also good. So here we have our 6, which is our default float. But if I just want it as 1, obviously then it changes it. Then we have also the floating point error, or if you divide something by 0, it's going to cause a problem. That's going to be the runtime error, a logic error. Then we have another thing called a memory exceeded, and this is where it comes down to performance, which we'll start slowly introducing as we're going along with the intermediate series, and also with more advanced programming, because it's all down to you have a computer, but you're sending it out to millions of computers around the world. Your computers may be super powerful because you're a programmer, but you need it to run on something that maybe your grandparents use, that are really, really old computers. They might have even Windows 95 on it or something really, and you need it maybe to be able to run. If it's a web application, certainly they need to be able to open up Internet Explorer, it would be in that case, and really legacy systems when it comes to it. Some software companies have constraints in place where they say they're not going to support those systems, and that's fine. That's absolutely perfectly normal to do. However, the performance is still an issue, that you need it to run on older devices or on things that aren't up to a very high standard. Or you might be an Android developer and need it to run on phones that have low memory as well. So with that kind of stuff, we have memory exceeded limits. So with data structures, which we introduced already, and we've only introduced a few so far, we've got arrays are data structure, array lists are data structure, methods using the last in first out is a data structure as well. And these can be, if you have too large an array, that will cause a memory exceeded to its limit as well. Okay, so I think they're the most common. Obviously we covered already the array index out of bounds, and that's when we have our in our for loop, if we're looping through the array and it goes 4 and then int counter is equal to 0 and then counter less than or equal to the array dot length. and the equal to is going to exceed the index. So it's going to be out of bounds because the length and the index, which I mentioned already, is not going to be compatible. So it's going to think, oh, we've got 10 elements, but we're going as far as 10. No, we're not going as far as 10. We're going 0 to 9 because it's the zero-based counting. 10 elements, but 0 is the 0 to 9, 9 is the 10th element. So that's it for today. I hope you enjoy the videos. Please subscribe, press a like if you like the video. I'd like to hear some feedback. If you have any feedback, send an email to learncomputerswithali@gmail.com. I've now enabled comments as well, so you can comment below. And thanks for watching. Happy programming.